All right, we have reached the last section of Unit 4, which is on something called variation. Basically, this final section talks about if you have multiple variables, looking at how are they related to each other, or how does one affect the other. So there's going to be basically three types of variation, or three ways that things can affect each other. The first one is called direct variation. Then we're going to have something called inverse variation. And the third type is joint variation. And we will also be looking at, it's not really a type, but if you combine multiple types together in the same problem. So let's start off with the most basic type, direct variation. If two variables are directly, or if they directly vary with each other, they can always be written in the form y equals k times x. And this k stands for the constant of variation. So k is going to be a number. It might be 10, it might be -3, it might be 7.018. It's a value. And if something, or if two things are directly, if they vary directly with each other, what ends up happening is as one variable increases, the other variable also increases. As one variable decreases, the other variable decreases. An example of something that would follow this could be the temperature outside and my air conditioning bill. As the temperature increases, I can probably expect the amount of money I pay for my air conditioning to also increase. As one goes up, the other goes up. They are directly affecting each other. So let's try an example. The volume of blood, which is going to be B, in a person's body varies directly, that's key for this problem, as the body weight W. So what we can do right there with that beginning information, they told me the volume varies directly with the weight. Before I even do anything else, since it said varies directly, I know I'm going to be using this setup, because they vary directly. However, instead of y and x, I am going to use b and w, because those are the variables I'm dealing with. Okay, that's like part one. So now it says a person who weighs 160 pounds has approximately 5 quarts of blood. So what we want to do with that information, the next step is we're going to use those values to figure out k. We have to figure out how these things are actually connected. So my 160, would I put that in for b or w? And you should say w because it is a weight. And on the other side, we have 5 quarts of blood, so that's b, that's the volume. So now I'd like you to solve for k, so I can divide. So k equals, if I left this as a simplified fraction, 5 will go into both of those numbers. So we could write it as 1 over 32, or if we use a decimal, I would ask that you keep a few places out. In my math lab, you will have to look and see how it wants the value entered. It will either say keep k as a fraction, or it will say keep it to blank many decimal places. You'll have to see what it wants. So now once we found k, we're going to go back to our equation, and we're going to write it, but I'm going to fill the value in for k. So I've made my equation, and I know now what my constant is for k. The final thing is they're going to give me some kind of a question or some kind of problem to solve. So it says, estimate the number of quarts of blood in a person who weighs 200 pounds. So now that we know how B and W are connected, we can now use this to find other information. So if I know a person weighs 200 pounds, what would I do with the 200? I'd plug it in for W. And I'm going to multiply those together. And again, this is where on MyMathLab, you're going to have to watch to see how it wants the answer. It might tell you to round, it might not. Make sure you pay attention to that. Let's go 2 decimal places. So if I multiply those together, I get 6.25, and now I want to label. What is this representing? Well, it's representing the volume of blood. So that's quarts. So what does this mean? Well, keeping this relationship consistent, if a person weighs 200 pounds, I can estimate that their body will contain about 6.25 quarts of blood. Let's try another one. The distance s that a body falls from rest varies directly, there is the key, varies directly, as the square of the time t. Okay, let's start right there. So I want to vary directly. So that's going to be my setup. However, I'm going to use the variables for this problem. So they said the distance varies directly with t. Now, if you have just this, you're going to get the wrong answer because it says varies directly as the square of the time. The square of the time. So we would actually see t squared. Okay, now let's see if they've given me some values. If skydivers fall 64 feet in 2 seconds, let's stop right there. Let's use that information to find k. So 64 is my distance, 2 is my time. So let's see here, 2 squared is 4, and then I want to divide. So on this one, k comes out to a whole number, 16. So let's write our equation now that we know k. So s equals 16t squared. Now they're probably going to have me use it. How far will they fall in 4.5 seconds? So now that I have my connection, I'm going to plug in my 4.5 and figure out what distance would that be. Okay, so make sure when you're putting this into the calculator, we square our value and then we multiply by 16. And I believe this comes out to 324. And I'd want a label on this. What does this represent? Well, how far will they fall? So feet. So in 4.5 seconds, they would fall 324 feet. Okay, same thing, only this one is not in a story problem setup. So y varies directly as x. There is that key phrase. So I know I'm going to start with this. And I'm going to use y and x this time. So it's great. That's good to go. Now let's see. Okay, they give me y is 65 when x is 5. So let's stop right there and use that to figure out k. So I'm going to divide by 5. We get 13. So let's write our equation now that we know k. Now they're probably going to have me use it to find something. Find y when x is 12. So 13 times 12. The value of y should be 156. All right, moving on. The next type of variation that we have is called inverse variation. And this is almost the exact opposite of direct variation. So if two things vary inversely, this will be their setup. So notice a way to kind of remember the difference between the two with direct variation, see how x and y are directly across from each other? Inverse variation, it's like y is up top, but the x is on the bottom. They're not directly across from each other. And what ends up happening here, as one variable increases, the other variable decreases. So as one goes up, the other goes down. An example of this could be as the temperature decreases, the amount of clothing I wear increases. As one goes down, the other one goes up. So don't let these story problems throw you off. It looks like, oh my gosh, look at all of those words. We're going to pull the important stuff out of it. So when you use a spray can and you press the valve at the top, you decrease the pressure of the gas in the can. This decrease of pressure causes the volume to increase. So right away, that's kind of a hint that we're going to be dealing with an inverse variation problem, because as something is decreasing, another thing is increasing. Because the gas needs more room than is provided in the can, it expands in spray form through the small hole near the valve. In general, if the temperature is constant, the pressure P of a gas in a container varies inversely, there's the key phrase, as the volume V. The pressure of a gas sample in a container whose volume is, well, before we throw the numbers in, let's set up our equation. Since we're going to vary inversely, here's my setup. But let's actually substitute in the variables we want. So P and volume V. Okay, now it says the pressure of a gas sample in a container whose volume is 8 is 12. So we're going to substitute those values in. So the volume is 8 when the pressure is 12. So if I want to solve for K, to cancel out dividing by 8, I would times by 8. So my constant K is 96. Now let's write the equation. And now they're probably going to have me use it to find something. If the sample expands to a volume of 22 cubic inches, what is the new pressure? So if my volume is 22, they want to know what does the pressure come out to. Again, this is where you'll have to make sure you read directions to see how they want you to write the answer. Let's say I ask for 2 decimal places, the hundredths place. So if we divide, we would have 4.36, and what's our label? Since this is pressure, what were they measuring pressure in? Pounds per square inch. There would be my answer. Okay, now let's look at what happens if we combine types together. So combined variation really isn't a new type of variation. It's literally when you are combining direct and inverse variation at the same time. So let's jump right into an example of this. The owners of a Rollerblades Plus determined that the monthly sales S of their skates vary directly as their advertising budget A, and inversely as the price of the skates P. Let's stop right there. Okay. So notice we have direct and inverse at the same time. So let's start with our first variable, which was S. And I know I'm going to have my constant, because that's in both formulas. So if S varies directly with A, The question is, do you put the A up with the K, or do you put it divided by A? Well, since they vary directly, the A should be directly across from S. And then it says inversely as the price of the skates P. So that means P should be in the denominator because it's inversely with S. So there's my setup. Now let's see if they've given me information to find K. When $60,000 is spent on advertising and the price is $40,000, the monthly sales are $12,000. So let's substitute in. The monthly sales are $12,000, so that's S. Advertising was $60,000. And the price was $40,000. So we could solve this a couple of different ways, and it's kind of up to you. What you could do first is your 60,000 divided by 40. And what we get is 1,500K after dividing. And then I'd want to divide my 1,500 over. And we should get 8. So my equation, now that I know K, my equation would be S equals 8A over P. 8A divided by P. That's my equation. Now I bet in the next part they're going to ask us to use it. Part B says, determine the monthly sales, which is S, if the amount of the advertising budget is increased to 70,000. So S equals 8. My advertising is now going to be 70,000. And the price, well, they want me to still use the same price of 40. So I want to do that multiplying and dividing, and I will have my answer. If I do that, I get out 14,000, and what would be my label? Well, up top when they talked about monthly sales, it was pairs, so that's also, I would have that many pairs of rollerblades. All right, the third and final type is called joint variation. And what this looks like when you're dealing with variables, it's variation in which a variable varies directly, so you're going to see them directly across from each other, as the product of two or more variables. So what you might see happen is it might look like this: y equals k times x, just like a direct variation, except you're going to see a third variable. But they're still all directly across from each other. There's just multiple variables now, more than two. So let's try an example. The centrifugal force, C, of a body moving in a circle varies jointly, there's the key phrase, with the radius, r, and the body's mass, m. And inversely, there's another key word, with the square of the time t that it takes to move one full circle. Wow, a lot of information here. So let's start with C equals, and then my constant k, and it said it varied jointly with r and m. So they're both directly across. They vary jointly. But then it said inversely with the square of the time. So I'm going to have a t squared in the denominator because remember, inversely means they're not directly across. One's up top, one's in the bottom. So there's my setup. Now I bet it's going to give us some numbers here. A 6-gram body moving in a circle with a radius of 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000, I think that's dynes. Let's see if we can substitute all those numbers in. So C is the here I'm saying around centrifugal, or never mind. You know what I mean. So C is 6,000. Reading skills, I tell you what. R, my radius was 100. And M was my mass. Did they tell me the mass? Yes, 6 grams. And T was my time that it takes to make 1 revolution, which was 2 seconds, but it's squared. All right, so I want to solve this for K. So 6,000 equals, that would be 600K over 4. Let's actually do 600 divided by 4, and I want to know what that would be. So if you divide 600 by 4, we get 150K, and then divide both sides by 150. So K is 40. So now my equation is C equals 40 Rm divided by T squared. Now they're probably going to have me use it. So find the force of an 18-gram body moving in a circle with a radius of 100 centimeters at a rate of 1 revolution in 3 seconds. So I'm looking for the force. R, my radius is 100. My mass is 18. And my time was 3. So if I do all that multiplying and dividing, I believe we should get out 8,000. And now I want a label on this. If I look back up, what were they measuring that force in? They told me up in the first sentence, where was it at? Right here. Dynes. I think I'm saying that right. And the very last example is what we were just doing, but it's not in story problem form, but it's the same concept. So y varies jointly as m and the square of n, and inversely as p. So let's write that equation first. So y equals k times m times n squared, because it's the square of n, all directly across from each other, but inversely with p. So there's my equation. Now they're going to give me values, so 15, 2, 1, and 6. I'm going to use that to find k. So 15, 2k over 6. So that would really be, if I simplify, k over 3, divide both by 2. And I'm going to times the 3 over. So my k value should be 45. So if I write the equation, (45) times m times n squared over p equals y. And now they're going to ask me to find something with it. So find y when m is 3, n is 4, and p is 10. So if we do all of our multiplying and dividing, make sure you're trying this in your calculator to make sure you can get the answer. I believe you should get y equals 216. So watch out for those key phrases, because that'll tell you how to set it up.